afternoon, everyone, and welcome to CalypsoAI's latest Responsible AI conversation featuring Andrew Spage and Brendan Quinlivan. Thank you for joining us. Our Responsible AI conversations are an ongoing series of live virtual events highlighting various aspects of responsible AI and the elements that go into achieving responsible AI. Today, our panelists will be discussing approaching ML security with a 360-degree approach. Before I introduce our speakers, we do have some event housekeeping. This conversation will be 30 minutes long with time for Q&A at the end. If you would like to get involved in the conversation, please submit your questions into the chat feature in your Zoom window. We will circle back to the questions at the end of the event. You have automatically been placed on mute, but if you should find yourself unmuted during the webinar, please do remute yourself. Finally, we are recording this session today and we'll share it with all registrants post-event. So keep an eye out for an email with the video in the next few days. With that, I'd like to welcome Andrew Spage and Brendan Quinlivan, who will be having a conversation together on CalypsoAI's unique approach to AI ML security. Andrew Spage is the Vice President of Solutions Architecture at CalypsoAI, where he leads the implementation of our solution with our federal customers. Brendan Quinlivan is a data science manager at Calypso, and he is one of the brains behind the big ideas driving our product offering. I'd like to thank them both for joining us today. And with that, Andy, Brendan, over to you to get the conversation started.
Thanks, Anna. I appreciate it. And thanks for everybody for taking time out of your precious time out of your busy days to come spend a few minutes and talk about this important topic. Like Anna mentioned, I think the first thing we wanted to kick off with, and I'll open it, and then Brendan can jump in and correct me, but AI security is a big deal in terms of the customers that we're working with. In particular, with the Air Force, for example, we're doing a great deal of work with them to both understand within the department, what does AI security mean? How does it differentiate itself from other security concerns, in particular cybersecurity? And how can we do, what can we do to address it and make sure that we're operating in a secure environment? Certainly, anytime you add a new element to an architecture for a deployed system or for whatever's operational, you're creating a new service area for an attack. In addition to that, if you consider a new capability that is game-changing, like AI is, in terms of its contribution to mission, to get left of boom, to speed decision-making, to provide greater situational awareness, all those things, that is an attack surface that somebody's going to want to defeat pretty quickly. So if you recall back when we had Star Wars, we introduced this idea of the ability to defeat a long-range bombing attack from Russia, a missile attack. And so that resulted in the end of the Cold War, not to put too fine a point on it. But in terms of the work we're doing with the Air Force, is focused on AI security. In terms of particular concerns, mostly it centers on the data. It sort of begins with the data and understanding how the data has been developed and curated to support model development, how data is perceived in runtime, and how the model will understand what it's seeing. Are there denial and deception things that an adversary could undertake to defeat a model's decision-making ability, and those sorts of things. And so we've been working on developing solutions that address those kinds of concerns. In addition, things like backpropagation testing, understanding if a model is deployed on a drone, what would happen if an adversary got a hold of that? Could they backpropagate it and understand or have insight into the training data that was used to develop it? And that's a particular concern when oftentimes the data that's used in those models is classified. And so you wouldn't want to let that out. In terms of other tests, I mean, I could talk for days and I'll let Brandon jump in here, or Brendan, I should say, in terms of other things like black box and white box attacks, where a model can be observed and its outputs can be assessed and understood by an adversary so that they could undertake the development, a very focused effort to develop efforts to undermine that model and its performance, as well as anything else they could do to defeat it. But let me stop there. And Brendan, I don't know if you have any thoughts on this topic.
Yeah, nice. Thanks for the intro, Andy. Really, really helpful. I guess one thing we should maybe touch on is that we're talking about AI security here, and AI is a really broad field, right, with lots of different subdisciplines. Could you maybe give an overview of the types of problems in as much detail as you can? I'm sure lots of it is pretty confidential. But like, are we talking here about computer vision models, tabular data, NLP, audio? With the clients you're working with, where is the focus at the moment?
So it's almost all on FMV or computer vision. So automated
Cool.
detection, automated classification, that sort of thing.
Nice. And then FMV for folks maybe who are listening just means full motion video, right? So if we're dealing with video streams rather than still images, oftentimes, right, the models that are being deployed in those cases are similar, but the way we test them actually can end up being quite different. Nice, Andy. That sounds really interesting. Yeah. So I think one thing that's worth mentioning is that we're talking about AI security, so the security of your AI models, as opposed to something Andy did also mention, cybersecurity and the use of AI for cybersecurity. Those are two different topics. Both are super interesting. The use of AI for security, so things like endpoint protection and insider threat detection, these kinds of things. It's been a really active field for the last 5-10 years. It's not going to be the topic that we speak about today too much. Instead, we're going to be focusing on the security of your AI models. So no matter what you're using AI for, whether it is in computer vision, NLP, tabular, if you have this automated system that's going to be making decisions that are really critical for your business use case, or for obviously in these military settings, if you have boots on the ground and the decisions of these models are actually impacting how missions go and how troop movements are affected, then you really want to be very confident in the security of that model, that it's not going to be easily manipulated by inputs in some way. Or now we can go into this in more detail throughout the talk, Andy, but there's two areas that we focus on Calypso. One is the side of adversarial machine learning. I can go into that a little bit more and explain what I mean, but it's when there's an adversary who's maliciously trying to change the inputs to your model to cause some sort of an issue. And there's a certain set of tests that we think people should be doing to be careful of that. But then there's also more benign things that can happen, like adverse weather conditions, or maybe you're using like a different camera, a different sensor to the one that you trained your model with, or there's like new compression artifacts being introduced, and all of these things can have a huge impact on the model. And so at Calypso, we think that testing for all of these types of issues that can pop up is critically important. And on your side, Andy, are you seeing, say with the Air Force in particular, where are they most concerned with these issues?
No, it's a great question, Brendan, and thank you for asking it. And I think your point about the adversarial attacks are really it's a really important topic, and I think there's more and more being done about it. And I know the research you and your team are working on are solving a lot, or attempting to solve a lot of those problems, and solving a lot of those problems. I think in terms of adoption, ultimately the end goal is to field systems. And so when you're looking at an AI program office or an acquisition program office, ultimately what their goal is to procure and field systems that support mission objectives. So in terms of security in particular, with regard to procuring systems, just the procurement itself is a big concern. The ability to bring in models and work with vendors to develop models, and then to test those models against various security criteria that might have been established either around their hardness against adversarial attack, or their ability to deal with somebody who is intentionally undertaking, I guess, what you could think of as a denial and deception effort to defeat models to fit decision-making ability, particularly think of putting on a hat for a facial recognition sort of thing. So understanding as from a procurement perspective, are the things you're buying, are they hardened against this, and how vulnerable are they? And then when you field them, what are the implications of that? So that's one aspect of sort of the issue that we think about when it comes to accelerating adoption. The other is how do we know that the data we're getting is good, is valid? How do we know that the training data is being developed in a way that optimizes model performance and that achieves model mission goals? Certainly, I've heard discussed things like insider threat, things like somebody who is intentionally manipulating training data. We wouldn't want to think about that in some classified spaces potentially, but certainly we want to be aware of it and be able to detect it if there's something that we need to be paying attention to there. And then the last is in terms of dynamic mission environments with regard to a model's ability to cope with variability in a deployed environment. And Brendan, that might be a good place to turn it over. I think, from the perspective of understanding how well will my model perform under certain conditions, and is it feasible even to develop my model to support either, let's say, for example, operating in a rainy environment or a cloudy environment or a smoke-filled environment, where, let's say, we're working in the visible spectrum and trying to use a camera, for example, to detect something. At what point does my automated detection begin to fail in its ability given the operational conditions? Brendan, I don't know if you have any thoughts on that, but I think there's certainly some security aspects of understanding exactly when a model will fail.
Yeah, 100%. And like I said, there's two main types of issues that we're testing for Calypso. One of those is in the adversarial space. And for those in the audience maybe who aren't super familiar with adversarial machine learning, sort of the canonical example that we always like to give is for a computer vision model that's trying to do image classification. And if you show it a picture of a cat, and it's probably going to, if it's a good model, it's going to correctly classify that picture as a cat. But what we've found is there's been a kind of a growing research field since about 2014, when some authors published a paper called "Intriguing Properties of Neural Networks." Is that you can actually make very small manipulations to that image of a cat and have the model misclassified as something else, so a raccoon or a dog or something like that. And the scary thing is that not only will the model misclassify that image as a different object, but it will do so with a high level of confidence. And the other thing that's really fascinating is that if a human looks at the image that's been manipulated, the two images side by side, the original picture of the cat and the new picture of the cat are going to look almost identical. Maybe there'll be like a little bit of noise or like a little bit of a discernible artifact, but certainly like it's still, to the human eye, it's still a picture of a cat. And so that was the birth of this whole field, which, like I said, the attacks have gotten more and more sophisticated. The defenses against them have gotten more and more sophisticated. And the types of things that can be generated have changed a lot. So originally, when we were talking about that cat example, we're talking about making alterations to the pixels of the image directly. And that's an interesting threat model from a security standpoint, because it sort of implies that, say you're in a situation where you have a camera that's collecting images in the field, an attacker would need to like get to the image after the point it's been collected by the sensor, but before it gets to the model, which is sort of like an interesting threat model that's, maybe a little bit questionable in some cases. But there's been this like whole new area of research around adversarial patches. And these are really interesting because it's a physical thing that you can print out and have in the real world. You can put it on a hat or a pair of glasses, your headphones, your t-shirt, and these things can fool the model in just the same way that those pixel manipulations can that I spoke about. Which is crazy, and we've demoed this internally, that someone can put on a t-shirt and effectively become invisible to an object detection algorithm, which from a security standpoint is honestly a little bit terrifying. But then the other area, which probably is what Andy was pointing to, is that we have a tendency as machine learning engineers, as data scientists, to, we tend to work with pretty clean data sets. And usually when we're doing a data science project, the first thing we're going to do is collect or find a data set, and we're probably going to do some cleaning operations to sort of get rid of the issue of the bad data that makes it hard for our model to learn and that it tests badly against. But the example that I like to give here is that if you're training autonomous vehicles to drive around California, as many startups are doing, when you deploy those to Ireland and the weather conditions in the background are like completely different, how do you know that model is going to perform the same way it did in sunny California? And I won't name any manufacturer names, but our CTO Jimmy did have an electric car with self-driving capability in Ireland, and he had all sorts of issues with some of the models that were running in that thing, and he had to get rid of it exactly for that reason. But yeah, so that's in the adversarial setting, there's a bad actor who's like maliciously trying to perturb your inputs in some way, or to do something very maliciously to affect the outcome of your model. But there's also these like just real world conditions. There's fog, there's snow, there's rain, there's image compression artifacts that can exist depending on how your data pipelines are structured. Like I said, you might train models on images that were collected during the day, but then you might deploy them to cameras that are collecting images at nighttime where they're using infrared to see. And of course, the distribution of your data totally shifts. And if you deploy a model into a setting like that without testing it first, you don't know how it's going to behave. And that, like, depending on what you're using your models for, that just has huge security implications. So yeah, Andy, I don't know if you're seeing, these seem like big concerning issues to me. Calypso, we think they are, but what are your of the clients that you work with? What's their perception of these things, I suppose?
No, I think so. I love everything you said, and I think everything you've said I've seen in one form or another, and it typically in where I come from, and having worked in the department in the intelligence community, it manifests in different sorts of ways. So things like that, we developed a model that is intended to automate the detection of tanks in a desert environment, right? And so, think Middle East or something like that. But then if you're thinking about the same sort of model and doing automated detection in a Gobi Desert or in some other desert somewhere else in the world, it typically doesn't work the same way, just because of basic things like, various gradients in the color of how light's reflected off the sand, the angle of the sun, the look angle of the collector. There's lots of different things that can sort of take your model and put it outside of its relevant range and its ability to operate. That's not to say that we're defeated. It just means that we need, if we're going to do some redeployment of models or diversify their applications, then it needs to be done carefully and it needs to be tested, right? Roads in Ireland are not the same as in the US, as I'm sure you can attest. There were a couple of things you were talking about that I thought it was sort of interesting to try and hit on as well. In terms of the conversation that takes place between an adopter and a developer is something that I think, and I'll go back to my comment about requirements and the acquisition aspect of this as well, is, requirements definition within the department, within the IC, they're really good at acquiring things. They're really good at planes, tanks, boats, all that kind of stuff, guns, munitions, and the requirements that they develop for those acquisitions are very, very carefully and precisely developed and then validated throughout the entire acquisition lifecycle. And that acquisition lifecycle makes it really, really easy to go to a warfighter and say, yep, if you take this shoulder-fired missile, it can fire, it'll have this range and it'll have this level of precision on hitting its target. And you can fire with the confidence that it'll do that. But when you take an AI and you're talking about saying, all right, well, look, it's gonna identify tanks with a 50% accuracy. Well, that's a different sort of con-op for an operator to be able to undertake and understand what that means, especially if it's going to be doing things like autonomous missions and maybe even targeting on its own, which is sort of I think the end game for some of these things. It just creates a different sort of dynamic in terms of how you communicate those requirements and how you undertake their use, the fielded systems into an operational setting and use them responsibly. And I think that's part of what we keep talking about with this notion of responsible AI. Testing for that is really, really important. You're probably not going to be able to get an AI, and I've yet to see one. And Brendan, feel free to put an academic spin or a more precise, actual sort of data science spin on this characterization I'm about to make, and feel free to call me wrong, but you're never going to get something that presumably is 100% accurate. Even with man-in-the-loop systems we have today, they can make mistakes. So there's always going to be some level of uncertainty that's present in any model that we develop. There's no way to eradicate it totally, but there is a way to understand it, and there is a way to mitigate it, defer it, whatever we need to do. So that's sort of a different risk equation when you talk about the department, when you're looking at eliminating risk with regard to missions. Now you're saying, well, we have to fix some of it, but we have to figure out how to understand when it manifests, how to detect when it's manifest, and know what to do when it does manifest. Brendan, do you mind? I mean, I don't know if you've got a more precise definition of that, but I think really what I'm trying to say here is there's got to be a better conversation between the data scientists, AI/ML developers, and the operators, and in a common language, in a common vernacular that allows us to be really, really precise about what it is we're developing and fielding.
Yeah, so I think a couple of things you said there are super, super accurate. So like the idea that like, as far as the state of the art goes today, and we keep very on top of this in terms of all the latest attacks and defenses, there's no silver bullet solution to any of these things that we're currently aware of. And there probably never will be, because it generally seems to be the case that generating novel attacks to fool these defenses seems to be a lot easier than generating robust defenses themselves. So we're always going to be dealing with some level of uncertainty. And it's our belief internally at Calypso that the best way to deal with that uncertainty is to have testing around it and to know what your limitations are. And so from like an MLOps perspective, if you're going to be developing a new model and deploying it, especially into these like really important military applications, you need to be doing this testing every time you're iterating on your model. So like I said, we have a suite of tools that let you, in a really, really easy automated way, test how your model performs in different weather conditions, against different data corruptions, and against all of these like cutting edge adversarial machine learning techniques that exist, also against these real world physical patches that we've spoken about. So really the best thing that you can do is, when you are going through the process of developing and deploying new models, you're running these tests against them every time. The problem that we see in industry is that like that's a lot of overhead and it takes a lot of work to do that. And that really is, I guess, the gap that we're trying to fill, is that we're trying to make this as seamless of a thing to do as possible. Like the easiest way to adopt a new habit, right, to do something that you should do, like whether it's going for a run every day or going to the gym, eating right, is to give yourself a healthy environment where it's easy to do the things that you need to do. And with the technology that we provide, testing a new model, say you have an object detection model that you're deploying on a tank, to use your example, Andy, and over the course of 6 or 9 months, you're iterating on that, and you're training new versions, and you're doing different fine-tuning operations to try and get that better and better. With our system, it's just a question, like, because your test data can exist in the system, you can get that all set up, and then just every time you have a new model, it's like one button to upload the new model, one button to run the tests. And some of this stuff is super computationally expensive, so you need to maybe walk away for a few hours or for a day, and you come back the next day and you have the results of all this testing at your fingertips, and then you know if you're moving in the right direction or not. You've got that signal. And we've come across a very small number of clients who are doing this type of testing on their own, but it's just like it requires fully dedicated people to be doing this, and to have it be uniform and easily accessible across a wide organization. Like that's really the value that I think that Calypso and one of our flagship products, Vesper Validate, is really bringing to the table. So yeah, how are you finding the adoption of that on your side, Andy, with the clients you work with?
I think it's very similar, and I think you hit on a lot of things that they're sort of experiencing. We're at the stage now, I think, where this notion of MLOps is becoming more and more present in conversations, and so that includes a lot of things from the data curation, first the data collection strategy with an AI goal in mind, and then the curation and the attribution of that data to support model development, and then ultimately the model itself. And so having this pipeline is really, really important, I think, from a repeatable process standpoint, because of the iterative nature of model development, but then also having this component of testing that fits into it, like Vesper Validate, and it just slides right in, and it makes it a natural sort of, once the model's developed, you can add this into the very end of the pipeline, and you're able to see how well your results are tracking with your mission objectives or your mission parameters that you have to align to. So I think absolutely everything you said there is certainly in line with that. But I'm watching the time very, very carefully, and I can see that we are absolutely less than 1 minute away from our Q&A session. So Hannah, if I can turn it back over to you for Q&A.
Yeah, of course. Andy, Brendan, thank you so much for that conversation. It's exciting to hear all the cool things Calypso is doing in the AI ML security space. So we are going to move to the Q&A portion of the conversation. To the audience, please feel free to add your questions to the chat box. And the first question I have for you both is about adversarial attacks. So you both talked a lot about adversarial attacks on ML models. However, a lot of people, what we've been hearing, they seem to think it's not a current threat, or the testing of adversarial attacks is not prioritized in pre-deployment. Can you please speak to how real and present these threats actually are?
Brendan, do you want to start?
Yeah, I can go take that away. Yes, so I mean, I think where that hesitancy comes from is with the first type of adversarial attack that I talked about. So when you're dealing, the cat's not the most compelling example, right? But when you're dealing with a picture of a cat and you're going in there and you're using the gradients of the model to manipulate the pixels of the image, like when you try and explain that threat to a security expert, they'll very quickly say that, like, well, in order to do that, someone may need to have some level of access to the model, and they need to have access to my data pipeline and be able to manipulate it. And that doesn't sound very realistic. There's bigger, more pressing concerns that I have on my plate today. I'm not going to think about adversarial machine learning, and that's where the conversation can stop. And I think that's a totally valid criticism of that type of adversarial machine learning testing. But where it gets really, really scary and really interesting is with the patches. So with these things that you can deploy in the real world. And we've seen this in a number of occasions now, but we've seen papers published where people have put a sticker onto a stop sign that is made a self-driving car recognize that as a 50-mile-an-hour limit instead of a stop sign, you know. So these things they're starting to come out there. As AI becomes more widely adopted, I think it's going to become more and more of an issue. And I think that people should be testing for it ahead of time before it becomes an issue, right? We should be proactive about this rather than reactive to a certain extent, because it's a real and present danger for sure.
And Andy, what would you say in the federal space?
So thank you, Brendan. I thought that was a great answer, and probably very similar to what I would say for the federal space. A lot of the discussion that I hear inside conversations with either existing or future, hopefully future federal customers, it centers on a lot of things like around, Brendan alluded to, attacks on the data itself. I saw a really neat framework that at least resonated with me in terms of how to break it down from an attack surface perspective. And it's sort of a three-pronged attack surface where you're either attacking the data and the data that's collected during prior to model development. You're attacking the model development itself from the perspective of either sub-optimizing on various aspects of model development, whether it be overfitting or these other things where it may not be as much of an adversarial attack as it is an exposure, if you will, an internal exposure, not understanding that you're overfitting a model and you're degrading performance for that. And then the last is in runtime, like Brendan alluded to, in terms of the patches that you'll see that'll a sensor will detect, it'll pass that detection over to an AI, and it'll make a decision on whether or not that's a stop sign or 55-mile-an-hour speed limit sign. There's discrimination as well, is another aspect of this that I've heard talked about from an adversarial attack perspective, meaning you're flying a drone and you're targeting a tank when a car actually is something that looks like a tank, and now you're going to target the car and it's a civilian family driving home from the grocery store, sort of thing. So there are things that in tradecraft that can span a number of different areas, and I think we're really just beginning to understand all of the different areas in which an adversary can do to deceive, and they're not dissimilar to things like denial and deception of that we've seen in like, for example, overhead imagery, putting a tarp over a tank so it looks like a bush, right? In the visible spectrum. So those kinds of things are also would be attack on an AI, so that you're missing a target or you're not understanding the situation or scene on a battlefield. But that's the kind of thing I think I'm hearing about, Hannah.
Right. Well, tying it back to kind of responsible AI more broadly, we are seeing a lot of discussion of responsible AI, both in industry as well in the federal space. And what are you seeing are the biggest gaps to actually implementing responsible AI?
I'll take a quick pass at it, Brendan, in 30 seconds. And I think what I see mostly is a need for a greater definition of the mission application. So where is the AI going to be? What is it going to see? How is it going to see it? Is it going to be operating in runtime? Is it going to be operating, in a real-time mission? Is it providing alerting? Or is it actually putting steel on targets? Is it operating in a data center, or is it operating in an AODO deployed setting like on a drone? These are things that need to really be considered when you think about what responsible AI means in terms of the depth and breadth of testing, the risk of deployment, and ultimately what it means to be accountable for deploying and fielding systems. Brendan, I'll throw it over to you.
Nice, thanks, Andy. I think we might have touched on this a little bit during the talk, so I might be repeating myself to some extent. But yeah, like I think the real burden here is making sure that, or the real goal here is to make the burden of testing as low as possible. So like I said, if these things are hard to do, if they take a lot of time, a lot of resources, then that's an issue that they're going to get pushed off for other high priority things in many cases. And then the other thing is having a standard language that you can have across organizations, across departments, across the entire industry. So having a standardized set of tests and metrics that you care about when you talk about these things, so that, you know, when you're moving from project to project, you can always have this apples to apples comparison by having your testing be standardized. I think that's a really important piece here.
Great. Well, with that, we are at time. So thank you everyone for joining the conversation today and for your questions. Also, thank you to Andy and Brendan for sharing your insights. As stated at the beginning of the event, you will be sent a recording of today's conversation to your email over the next few days. You should also see a survey that has popped up on your screen. We would appreciate your feedback to help us plan for future responsible AI conversations, and also to ensure we are having discussions that are meaningful to you and your organization. Also, please follow CalypsoAI on LinkedIn, where we post all of our latest news and content. If you have any questions following this conversation, please reach out to marketing@calypsoai.com. Thank you once again to everyone, and have a great rest of your week.